In this video, we're going to take a look at routing, what it is and why we do it. And first off, routing is the ability to move information from one network segment to another one. And one of the primary functions of a router is to be able to determine the best path to send that information or data on to. So, two important things we just said. One is routing is the process of moving information or data from one network segment to another, and routers have the ability to determine the best path to send that information on. Now, how they do that is with a routing table. And a routing table is configured one of two ways. We either do it statically or we do it dynamically. If we do it statically, we, the administrator, have to go into the router, use an IP route command, and we have to configure those routes to tell our router how to find another network or how to find the next hop router. Or we can use dynamic routing protocols such as RIP or IGRP. Now, if we use dynamic routing protocols, then the routers will share the information dynamically. As a change is made to one routing table, that routing table will be updated and then sent out over the wire to the other routers that are also configured with the same routing protocol. So let's take a look at my routing table that I currently have on one of my routers, and we'll talk a little bit about what's in it. First off, I did the show IP route command to get this. So you go up on any router, and if it's Cisco, and it has a Cisco iOS, and if you do a show IP route command from the privileged executive mode, then you can show the routing table. Now down here, we take a look and we see that I have some information that points over to some routes. First off, if it's preceded by a C, it's directly connected. And so what those two C's are telling you is that I have two interfaces. One's an Ethernet 0, the other one's a serial 0. And one of them is configured with a 204.10.50.0 address, and the other one's configured with a 204.10.20.0 address. Now, the ones that are preceded by an S, those are the static routes that were configured by myself. So I went up inside the global configuration mode, and I typed in IP route, and I just basically said, hey, look, if you're looking for network 204.10.0, you can find it by going out one of my interfaces and going to the next hop router, which has its interface configured with this particular address of 204.10.20.2. Now, what we did here was, of course, I'm talking about my serial 1 interface. On this other router is configured with that particular address. I am connected to that serial 1 interface by a WAN connection. And I'm saying that if you need to find any of these routes that are listed statically on my particular router, just go out my serial 0 interface and go hit the next hop router, and it'll have an entry over there to tell you how to get to it. That's why we did this statically. Alright. Now, why do we route? Why do we even worry about it? Well, we do it so that we can segment our network. We want to segment our network for a number of reasons. Let's talk about that real quick. We segment our network to keep local traffic local. That's one of the primary reasons we do it. Breaking up a network into smaller segments reduces congestion on the network by reducing the overall traffic load. It also increases the bandwidth available to each user. Bandwidth is a shared entity, but each segment and its users have full use of the bandwidth available. For example, if there are 100 users on a 100 megabit segment, each user has an average of 1 megabit of available bandwidth. If the same segment were further segmented into 10 more segments with 10 users on each segment, then every user would have an average of 10 megabit of available bandwidth. So you see why we start thinking about breaking up a large network into smaller segments. Also, we get fewer collisions. In general, traffic tends to stay within a segment. Also, reduces the Ethernet distance limitations that we have when we're talking about configuring networks. There are inherent distance limitations on the Ethernet network, and when a network is segmented with a router, and only a router, not a bridge and not a switch, the beginning point from which the maximum distance for the cabling is determined and reestablished. So here are some things to consider before you segment with a router. A router can segment a LAN that includes different media types. For example, a LAN may have both Cat5 and ThinNet coaxial cable connecting to a fiber optic cable. A router can interconnect LANs that are using different protocols just as long as those protocols are routable. A router does increase the latency by adding the delay caused by the router examining each packet before it sends it on. And a router can also provide more than one active link or route to a destination. And on a large LAN, this is what we call providing diversity and redundancy, which are both very good things. Now let's talk about the specific benefits of segmenting with a router and why we do it. We get the reduced size of broadcast domains. Routers block broadcasts unless specifically instructed to forward them. We also get smaller networks. Routers create smaller networks as opposed to dividing a large network into smaller pieces of itself. We also get flexible addressing. Routers segment a network by using logical rather than physical addressing. For example, a bridge uses a MAC or a physical address to make its addressing decisions, whereas a router uses a logical or the IP address. And of course, we have that wonderful benefit of better administration. A system administrator has more management tools available when using a router, thanks to the increased memory in the router and its ability to make routing decisions based on a multitude of factors. Now, with all that being said, imagine having a very large network. Let's say you've got a large network with 1,000 users and they're all on the same segment. If you have a problem on the network, you're going to have to troubleshoot it in its entirety. Now, if you had that large network segmented into, let's say, 10 segments, and you had a problem on one segment, now you were able to at least isolate it down to just a small part of your network, as opposed to having to look at the entire network. So there's some more benefit into routing and breaking up our very large broadcast domain into smaller broadcast domains. And later on in this series, we're going to take a look at static routing. We're going to look at the null-zero interface. We're going to look at stub networks. We're going to look at the default route. And we're going to look at dynamic routing as well. And we're going to focus on RIP and IGRP.